Just going to move you guys over. Chat. I'm going to say, so now I'm going to do this.
Oh, I keep forgetting my glasses.
Whoops. Okay. All right. Can you see, Cliff?
Yeah.
Okay. I'm just going to do number 2, you said?
Yeah.
Okay. Could just be the way you set it up as well.
No, I did it every which way and it still comes out wrong.
Okay. I want to say Tanis is supposed to be watching from home. I want to see if she's here. All right. So number 2, a kite string is 350 meters long. The angle the string makes with the ground is 50 degrees. How far from the person holding the string is a person standing directly under the kite? Okay. So let's see. I know there's a triangle involved, right, Cliff?
Yes.
The angle the string makes with the ground is 50 degrees. So this is 50 degrees, right?
Yeah.
Okay. How far from the person holding the string is the person standing directly under the kite? This is the kite then, right? The kite's up in the air. This would have to be the person holding the kite, right?
Yeah.
Okay. So this is the person under the kite.
Yeah.
How far away is the person holding the string from the person under the kite? So I'm looking for this. Agreed?
Yeah.
The only thing I didn't label yet, the kite string is 350 meters long. So this is the kite string. Okay. All right. So what trig ratio am I going to use?
You'd be using the adjacent and the height, so that would be the adjacent and cost.
So Cliff is going to use cos. Do you agree, Dee? Cos? I agree as well because this is the adjacent, right? This is the hypotenuse. So it should be cos and hopefully it would work. So cos of 50 degrees equals adjacent over hypotenuse. The x is on the top. So it's a times. Make sure you're in degree mode, I suppose. That might be an issue, right? So it's going to be x equals 350 times cos 50. And I get 224.98 meters.
Yeah, I got that before, but on the back it's like 500.
Okay, let's just do a quick double check there. Actually, I'm just going to leave this. I'm going to go grab another book so I don't have to go flipping pages. So we're looking at assignment 6. Number 2. No, it's right here, Cliff. Assignment 6, number 2, 224.98. Yeah, assignment 6, number 2. The answer is correct.
That's that one. 544.
are you using? I'm gonna have to give you a different book. Yikes. Sorry about that. Okay, so I'm using. Oh no, hang on.
Oh yeah, I got the right one right here.
Yeah. I don't know what's happening, but I'm using the book that's printed June 2019. I'll put the PDF of this
one's
book
February
online.
19th.
Yeah. So, okay. So just, there's nothing wrong with the examples prior, but just keep using, I guess, oh. Okay. Okay, that was my error again. All these booklets are so, okay, what else? Are we good for this stuff then? Hopefully those questions will, excuse you,
Number 6.
number 6. Okay, a ship is on the surface of the water and its radar stream detects a submarine at a distance of 238 feet at an angle of depression of 23. How deep underwater is the submarine? Okay. Okay, so these are tough, right? Because angle of depression means you're looking down on something. So, but it makes sense. This would be another application where you'd be looking down on someone. Here's the water, right?
Yeah.
The ship would be on top of the water. So anything, it says its radar detects a submarine at a distance of 238 feet away from the ship, right? So 238 feet away, there's going to be this submarine, right? So I'm just going to put a big dot here. This is the submarine. That's what I know so far, right?
Yeah.
Angle of depression of 23 degrees. So this time actually, this would be the angle of depression, right? The way I described it. Can you see? If I was on the ship and I'm looking down, this is the angle of depression. Agree? Wouldn't it be? Because the angle of depression is like taken from the ground, wherever you're standing down. So in this case, we got lucky. This is the angle of depression. So how deep underwater is the submarine? You might be tempted to say it's 238 feet deep, but that's not really, that's not the closest. Like this is actually the how deep it is, right? So this is what I'm looking for. So what trig ratio am I going to use? What sides do we have here?
You got to use the hype and the op.
Yep, we've got the hype and the op.
Sine?
Yep. So it's going to be sine of 23 degrees equals x over 238. Once again, x is on the top, so x equals 238 times sine 23. So I get 92.99 feet underwater.
I think I did it a different way.
Did you get the same answer?
Yeah, but I used 67 degrees.
Okay, that's all right. So then you used this
But I
angle?
used cos too.
Yeah, if you use 67 degrees, you would use cos. That's fine. You're using different parts of the triangle, but you're finding the same side that you're supposed to find, right? So that's fine. That's it. Anything else? Have you ever done trig before, Dee? Years ago? Did you ever learn about the sine law and the cosine law? Or do you remember learning about sine, cos, and tan? Kinda. Did you ever learn the law of sines or the law of cosines? Okay, so that's new stuff. That's the new stuff for this course, for the grade 11 course. Should I go on and introduce those then? Because this will be our last class together, right?
Yeah, might as well.
Cliff, could you close it? Thanks. Okay, I'm going to introduce, this is it says on your cover page, right angle trigonometry, oblique angle trigonometry. So I'll just kind of do a quick summary of why we have some more trig that we have to learn. So far in your math career, and what we've been talking about in this class, is we've just been solving for parts of right triangles, okay? And do you remember what right triangles, what that word right means for a right triangle? Yeah. So all of our laws so far have just been pertaining to right angle triangles, right? All the sine and the cos and the tan ratios, when they're just these ratios, like the op over the height, the adjacent over the height, or the op over the adjacent, those are just used or can only be used for right triangles. So they have to only be used, these can only be used for 90-degree triangles, which we've seen they're great, they're powerful, they can solve for missing sides and missing angles. But the problem is our world involves many kind of triangles, and most of the triangles we have, like, and those weird looking triangles like this, all of these triangles don't have a 90-degree angle. I can't use these laws in those. So for non-right triangles, and there's more non-right triangles than there are right angle triangles, we use different formulas. The right angle formulas won't work for us. So we use the sine, it's called the sine law or law of sines, and the cosine law. Now they both have the cosine law, there's only one law each, so it's kind of nice in a way. But the beauty is we can use both of those laws to solve for sides and for angles. Just like these guys, we use them for sines and angles. We can use these guys for sines and angles. They're a little more complicated looking when you first look at them. But when you start working with them, to be honest, they're not that hard. And most students kind of, I think, enjoy.
So you only use the sine and the cos for these ones?
Yeah, there's no tangent law. It's either the sine law or the the sine law or the cosine law. Okay, so let's see what the sine law says. And actually, the sine law in particular seems to really, people seem to enjoy that one. Okay, because it's very straightforward. So I am on page, where am I? I don't know what page I'm on, but use your new booklet, okay? Use the one that says June, the updated one. Okay, so I'm going to work on something called law of sines, and it says, use the law of sines to solve for unknown sides and unknown angles for oblique triangles. All right, that word oblique, the word oblique just means it doesn't have a right angle, right? They're not non-right angle triangles. So get used to that word. It just means, this means non-right triangles. Okay. So triangles that don't have a right triangle are called oblique triangles. For oblique triangles, we can't use the same trig ratios. We use the law of sines, the law of cosines. Okay, our first lesson today, and this is crucial, this is going to be both for law of sines and for law of cosines. We have to learn how to label triangles. Now, we're not using hypotenuse, adjacent and opposite. First of all, there is no hypotenuse. There's only a hypotenuse if we have a right angle, right? There's no hypotenuse. If there's no hypotenuse, there's no opposite, no adjacent. So the labels are very simple. We call the angles, so these are the angles, right? The corners, that space between the two sides that make a corner. The angles are labeled with capital letters and the sides are named with lowercase letters of the English alphabet, okay? We don't use any Greek letters in this numbering system. Well, you could use a theta again, but notice again, capital A is partners with little a, the side right across from it, they're partners. B has little b partner and C has little c. Now, it doesn't have to be A, B, and C. It could be any letters of the alphabet you want. Let's use K for Kim, C for Cliff, and D for D. If I label them those, this side would be little d, okay?
Yeah.
This side would be little c, and this side would be little k. Okay, got it? It makes a difference. The partners are the side opposite whatever angle you've labeled, those are the partners. The relationship between the angles and their partner sides is as follows. The length of little a divided by the sine of angle A, and we know sine of angle A is just a number in our calculator, exactly equals little b over sine of B, and it equals little c over sine of C. So this gives us a set of ratios to use cross multiply and solve for, just like we were doing before. You'll notice there's three ratios here, or three fractions, because we have three sides of a triangle. You'll only ever use two of them at any given time to solve, right? Because we just use two for cross multiply, okay? So, using the law of sines to find an unknown side length, okay. Now, this A, B, and C setup, it's only used like in general terms, so you know who goes with who. It gives you a labeling system to establish partnerships. But when I approach a question, I don't label things side A, B, and C, because I think that confuses matters. But you tell me if this works for you. All I do is I look at a triangle and I look to see if there's a partnership, a clear partnership where I know both of the numbers, like both identities. And I can see here I do.
That's 43 and 26.
Angle 43 is partners with side 26. Agree?
Yeah.
This is sort of a partnership, but it's only a half partnership, right? So I know that 26 partners with this angle measure, but remember this is the law of sines. 43 degrees can't exist on its own. It has to have sine to support it. A degree number has to have a sine or a cos right in front of it, but this is the law of sines, so it's going to be sine. 26 partners with sine 43. Okay, so the other partnership is X partners with sine 62, agreed?
Yeah.
You can see I have a nice cross multiply setup. Now, I don't know if you remember this before, but when we cross multiply, we know that these two numbers multiply and equal these two numbers, agreed? So I know that X times sine of 43 equals 26 times sine of 62. Agreed? That's what cross multiply means, right? These two have to equal these two.
X times.
Right? These two have to equal these two. That's all I've set up here. Now, I want to solve for X. So how do I get rid of this sine 43? I divide it out, right? Right now, X is being multiplied by sine 43. How do I get rid of that sine 43? I divide it out. Just like we did, that's how we solve equations. Whatever I do to one side, I do to the other.
26 times
Because a sign on top, a sign 43 on top and bottom cancel each other out. So in the end, my calculator steps are 26 times sine 62 divided by sine 43. Okay, let's stop and just summarize what we've done.
26.
After I do my initial setup, like wait back here, if I look from this first step to the last step, the only difference is, so I know these two multiplied equal these two, right? But if I want to know my unknown, this is the shortcut. So you might want to just watch this for a sec.
Right.
When I have a cross multiply, my cross multiply, I have to know 3 out of the 4 numbers. There's only going to be one number that's unknown, right? That's how cross multiply works. So to figure out what this number is, I multiply the two numbers that meet at a cross, right? I multiply these two numbers and I divide out by the leftover number. That's always going to work, okay? So in my calculator,
You multiply 26 and 62.
yeah, sine 62, 26 times sine 62 divided by sine 48, or sorry, 43. Okay, so x will equal 33.66 feet. Okay. Let's try this next one.
So hold on. And then you just go straight to the division,
Yeah.
divided by 43?
Yeah.
Or sine
Sine
43?
43.
Oh,
Are you in degrees?
Yeah.
Try it again. 26 times sine 62 divided by sine 43 divided by
divided by sine
43.
43.
Enter.
25.99.
Press mode.
26.
Press mode for me. Just make sure that degrees is highlighted.
Yeah, degrees is highlighted.
Okay.
Clear.
26
times
Sine.
43.
sine 62.
Oh,
26 times sine 62 divided by sine 43.
So here's 25.99.
Yeah.
26 times sine 62.
Close your bracket.
How do you do that? Twenty-six times sine
See how
62.
they opened a bracket here? Close it off.
Oh,
Okay.
okay. And then divided by
Yeah.
sine
62, 43.
43.
Mhm.
You close the bracket again?
Yeah.
Oh, yeah.
All right, let's try the next one. All right, have you worked ahead a little bit, Dee? Okay, let's see if you get, so do I have a partnership? Do I have a complete partnership here?
Yeah,
Which numbers are the partnership, the complete one?
76 and 46,
Thanks, Dee.
right?
It's not 76 and 46. It's 46 and
76.
sine 76. Okay. Then X is partners with sine of 35. Same thing, right? So if I want to solve for X, I multiply my two numbers that meet at the cross, and I divide out the guy that doesn't have the partner, right? So it's going to be 46 times sine 35. So D, you're using your own calculator, right? Okay. The graphing calculators open up a bracket, so you're going to have to close the bracket off. Divided by sine 76. And the graphing calculator automatically opens it up, so you have to close it off. Okay, so what do I get here? 46 times sine 35 divided by sine 76. 27.19 meters. So the ratios that you set up, they have to be, you have to set them up and their partners, right? Once you have your cross multiply, right? So the partner sits on top of its partner angle.
Angles are always at the bottom, eh?
To be honest, it doesn't really matter. You can put the angles on top, but if I put the angle
As long as they're across from each other.
right, if I put the angle on top here, it would have to be on top here.
Yeah.
The cross multiply would end up looking the same.
Mhm.
But okay, let's try our last one. Let's take a look. Do we have a partnership? Yes, we do, right? Whoops. Yeah. Partnership, agreed? 52 and sine 29 are a partnership. What's the problem here, though? What's my next problem? When I'm supposed to solve for X, when I look for X's partner, it's not there. And I could do 80, but 80's partner would be something that I'm not asked to find. I'm asked to find X. I'm without a partner angle. What do I have to do here? I have a problem.
You gotta find the other side. Or the other angle.
Yeah, I'm not asked to find the other side, so I don't care about the other side. But I could easily find this angle. How could I find that third angle that's missing?
Just multiply.
What?
180
Yeah,
minus
the 180. If you're missing an angle, it's absolutely no big deal if you know two of them. So
180
this is going to be 71 degrees, right? Okay. Problem solved. So X's partner is sine of 70. If you're given X to find, you always have to find his partner angle, right? But that's
Why did they
easy.
even put an 80 there then? Oh, just so you can find
If
the
they
other-
didn't give you the
you'd be able
80,
to find
you wouldn't be
that.
able to find it.
Okay.
Okay, so I want to solve for X. Remember the process? Multiply the crossed numbers and divide by the guy who doesn't have a partner. 52 times sine 71 divided by sine 29. Whoops. Okay, 101.41 centimeters.
Is this the last of the booklet here?
No, we have two more. I Did I give you guys, I thought I gave you guys copies yesterday of the last 2 booklets that you'll do. Did I? I came yesterday, so I handed them out yesterday.
Yeah, I got it. I think.
Did you get D, intro to graphing, measurement, intro to quadratics?
Yeah.
So those are the ones I'm gonna do, like, I guess during our isolation period, I'll just be broadcasting every day.
And I can just go straight, like, show me before, I can go like, WEC, and then just look up your name.
Yeah, so what I did, I'll show you guys something.
Yeah,
What do you wanna do? Do you want me to stop right now, or do you want me to go on?
go on, because I'm not gonna get it. So.
What'd you say? Continue on? Okay. So before we leave, I'll show you, okay? So I'll keep going on. And then, yeah, you can just watch these later too, right, Cliff? So just watch. Don't even do them today if you don't want to. Just watch.
I
Okay.
wanna do them, I just don't get it sometimes.
Yeah, no. No, I mean, you'll be able to get the notes later anyway from the blog, right?
So I can figure out how to do that.
Okay, so as we know, remember sine, cosine, tan, we found missing sides, missing angles. Law of sines, it's kind of nice because it's really easy to find missing sides or missing angles. Now we're going to use it to find an unknown angle measure. But we do the exact same thing. We look for partners. There we go, partners, agreed?
Yeah.
Set up the partners. So 36 partners with sine 60. 27 partners with, well, this is my unknown, right? So I'm just going to record it as sine theta. All right. So I cross multiply again the numbers that I know for sure, right? And then I'm going to divide out the guy I don't know. Agreed?
Yeah.
So if I was solving for sine theta, I am going to multiply 27 times sine 60 divided by 36. Okay,
Sine 36 or just 36? 36.
by 36, right? Because we're solving now. Pay close attention to this one. And D, you might be able to do this one on your calculator easy, but if we're using the graphing calculators, do you have just your normal little handheld?
Yeah.
Okay. I want you to think about something. Just watch me for a sec. If I just type this in, right? I'm going to be solving for sine theta. And remember, we don't want sine theta. We want to break this off. So I really want theta. So I have to do, in addition to all this stuff, I have to do that one thing at the beginning, right? When you do your shift sign. So that's a lot to type in, right? Okay. So I'll show you a quick way to do it on your calculator, Dee, but if you're doing on the graphing calculator, this is what it looks like.
Sine 60.
Okay, you ready? Once you do it a couple of times, it's not that hard, and I'll show you another way, okay? So I go, if you're watching, so shift sign, right? You get that shift sign? Then I'm gonna,
Second?
yeah. 27 times sine 60. I just have to close that bracket off, divided by 36. And I'm gonna get theta equals 40.51 degrees.
Yeah.
Just try that on your calculator anyway. Do you see if you get it? So really, it's just one extra step. It's just doing the shift sign at the beginning. That's it. Okay, let's try one more. Do I have a complete partnership somewhere?
Yeah.
Which ones?
33 degrees and 39.
Yeah, partners, right? And then these partners. So set them up. 39 sits over sine 33. 62 sits on top of sine theta. So I'm going to multiply and divide. But I have to also get rid of that sign because I really just want to solve for theta. So I just have to make sure I just do that shift sign at the beginning. And then I'm just going to do 62 times sine 33. Just close those brackets off, divided by 39. And I get 59.98 degrees. Okay, try the last one on your own right now, and then I'll fill in the blanks in a sec. I'll do this last example and I'll get you to come up to the computer. So beta equals. Divided by. So. Okay,
I did wrong.
did you?
Yeah, I. Five by 50, right?
Okay, so theta equals 46.65. So that's it. You could do the law of sines now, the assignment. On Monday, I'll do law of cosines. And then we'll also see on Monday why we need the law of cosines, because law of sines seems to work great, and it does. But you'll notice that I can't start a law of sines question until I identify that there's a partnership, right? There has to be complete partnership for law of sines to work. What we'll see Monday is we might not always have a complete partnership, but that's why we need the law of cosines. So I'm going to stop streaming.